Hello everyone. Thank you for joining this webinar. My name is Sanjeev and I work for GL Communications. Today's webinar topic is air traffic management test solutions, and I am joined by three of our senior engineers, Rob Bichevsky, Srinivas and Nagaraj. So in this webinar, we will focus on our latest enhancements and solutions for the air traffic management industry. Just a brief introduction of about who we are and what we do. We've been around since 35 plus years, and we are a telecommunication consulting company. We also manufacture test and telecommunication test and measurement equipment for the telecom industry. We are headquartered in Gaithersburg, Maryland, USA, and we also have a development center in Bangalore, India. Also, we have several representatives who are working for us across the globe. Our test and measurement equipments cover testing of different telecom networks. We can interface to wireless networks, VoIP networks, ATM networks, fiber networks, TDM, as well as analog and old POTS network as well. So we can connect to pretty much any type of interface in any type of telecom network that you are interested in testing. We can do a whole range of different types of testing on these networks. We can monitor the networks, and we can also emulate traffic on those networks. We can also test the conformance and to different protocol standards. Our solutions help you to visualize the network, capture the traffic over the network, store the traffic for future analysis, and we offer these solutions in both portable as well as rack mount variants. They're quite cost effective as well. So going to the specific topic of today's webinar, we have the cutting edge solutions for air traffic management testing, voice quality testing, latency measurements, and conformance testing, and so on and so forth. So we have a whole host of solutions designed to test these mission critical networks. As many of you know, maybe you are all familiar with the thing that a whole industry is migrating to the VoIP. So all the legacy networks where they are, whether they are T1 even, 4-wire, analog, and all those legacy networks are being phased out, and everybody is migrating to the VoIP. But this migration is not very easy. So we face a lot of challenges during this transition, and there has to be an extensive testing that needs to be done, since these are mission critical networks where the pilots need to communicate to the air traffic control towers and vice versa. So the air navigation service providers must rigorously test all of this infrastructure for reliability, stability, interoperability, and of different performance metrics and so on. During this migration, you will find that a lot of these legacy networks still must be maintained and remain in use until the migration is completed. We have solutions for testing both legacy as well as VoIP portions of these networks, which is why GL is at the forefront of all of this. We work with many air navigation service providers. We work with various equipment manufacturers, government agencies, and contractors, and so forth. I would like to mention that GL is a member of the EUROCAE, and we also contribute in working group 67 as well. We do consulting services as well for the air traffic management industry. Here's a quick depiction of which shows the controlling working positions where Your air traffic controllers are sitting at the voice communication switches are there at those air traffic control towers. And then you have your actual remote radio stations which are communicating to those air traffic control towers and then relaying those signals wirelessly up to the planes in the sky. We can test over the wired portions of the network. So from the ground radio stations to the air traffic controllers, all of that is wired infrastructure, and that is where our test equipment sits and does the analysis and monitoring and emulation. We are compliant with all the latest ED-137B and C standards, and we comply to the ED-137-138 standards for monitoring purposes. We do critical delay measurements with voice quality as well. Note that our solutions are voter validated. Let me now hand over to Srinivas, who will provide a detailed insight into these solutions and give you a much deeper technical knowledge about the solutions that we provide for the ATM industry. Over to you, Srinivas.
Thank you, Sanju. Hello, everybody. So today we are going to discuss GL's ATM test solutions. So as you saw in the previous slide, like what are the challenges that during this migration phase the ANSPs or the airport authorities are going to face here. Okay. So keeping these challenges in mind, GL has developed a set of test equipments to address most of these problems or the issues. Okay. Okay. So our ATM test solutions are broadly categorized into three categories. The first category is the emulators. Okay, where we have three emulators, basically like the radio emulator, which will be simulating the air to ground calls, and then we have a telephone emulator which will be simulating the ground to ground calls, and third one we have is the recorder which will be simulating the recorder sessions for both air to ground and ground to ground voice communications. We'll look more details into these products later. The next category is ED-138 monitoring solutions, where we have two products, but both of these products work in tandem. Okay. The first product is a packet scan. Basically, it is like a IP probe, which is going to sit in the network and capture the packets non-intrusively. And it is going to identify the air to ground and ground to ground calls or the communications that are happening in the network. And then it will perform a very deep down analysis and gather, say, a very deep statistics, both for signaling and voice. Once it collects as and when it collects these statistics, it is going to send it to a centralized database in real time. Okay. And there could be multiple packet scan probes installed in the network, which is geographically distributed, and all of them can send the call detail records to the central database. The second product is the Net Server Web. This is a web application which allows the users to remotely monitor all the probes that have been deployed in the network geographically. Okay, so it provides all the call detail records stored in the database. It provides both real-time and historical data, and it also provides a lot of graphical reports which will help in quickly analyzing the issues in the network. So that is about the monitoring solutions. And the next category is about measuring critical delay and voice quality in the air traffic network. So as we know that since the industry is migrating to this new VoIP technology, so we are going to change the infrastructure, we are going to bring in the new devices, and we also need to work along with the legacy equipments also. It is not possible to replace everything in a one go kind of thing. Okay, so all of these requires a very stringent testing so that we adhere to the delay and voice quality standards specified by the specifications. Okay, so that the voice communication is good enough and uh, good enough for the ATC community. Okay, so for this one, actually, like we have a suite of equipments. Basically, these suite of equipments either they act as a probes, both in legacy and in the IP networks. And as a probe, they will induce the voice signals, PTTs, and other things, all the radio signals and all. And as and when these signals progress from one end to the other end we are going to record the voice and compare those transmitted and recorded voice for the voice quality, end-to-end voice quality. And we can have a probing devices for both legacy and IP networks. So these probing devices are going to detect the events as and when they occur on the network. Okay, and they are going to timestamp those events, and these timestamp events are used to calculate the delay. And this delay and voice quality is not just about measuring from end to end. It could be across the different networks like IP to IP, legacy to IP, or legacy to legacy. But it can also be, we also need to measure it across the devices also. Okay. Yeah, so this is a brief summary of all our ATM test solutions here. So now we'll go more detail into these emulators, the radio, telephone, and recorder emulators. All these three products are built based on a common framework that is called as a MAPS. MAPS stands for Message Automation and Protocol Simulation. Okay, so this framework we have used to simulate a wide range of protocols, telecom protocols basically. Okay, the advantage of this network is it allows to simulate hundreds of end nodes, and it allows to simulate hundreds of calls uh, by and it is all just a software based architecture. Okay, so and it also allows the as the name says, it allows to modify the messages, create our own call scenarios. Okay, so which will allow us to perform all kind of testing. Okay, so all our radio, telephone, recorder emulators are based upon this architecture. So let's begin with the radio emulator. So basically the radio emulator is going to simulate the A2 ground calls as per EUROCAE's ED-137 volume 1 radio interface. So it's a software only product, and it has a very user friendly and a very rich graphical user interface, which allows to configure and operate the software very easily, so that we can easily simulate the required air to ground calls. Apart from the GUI, we also provide the we also have a optional support for the Python APIs also. And yeah, all our maps emulators like the ED-137 emulators are based upon the Windows OS. So let's go into more details about this radio emulator. As I told, like to simulate this air to ground calls, the emulator can either simulate the controller working positions, or it can simulate the ground radio stations as per ED-137 specifications. We do support both B version and C version specifications. And as I told, the maps adds this advantage of creating multiple controller working positions or the radios in a single software. That is like with a single license, you can simulate hundreds of CWPs or the ground radio stations. Okay. And since it is a software and you can just install it on a laptop and carry it for the field testing or deployment testing and all the day-to-day troubleshooting testings and all. So uh, the emulator, radio emulator has been, all our emulators have been designed in such a way that it caters to all kinds of requirements, be it like functionality testing, FAT testing, site acceptance testings, or deployment testing. Okay, and it is for even for performing the load testing, uh, and it can even be used for the training the engineers, since we are migrating to this new technology and day-to-day field testings. Okay, so that is the advantage of this software here. We do support all the radio call types, the PTT types, and we can also modify all the SIP headers and the SDP attributes related to the ED-137, which have been defined in the specifications. Apart from that, it also supports the advanced features like link session management, multicast routing, or selective call tone transmissions. Okay. And this emulator, it supports both IPv4 and IPv6 addressing, and we have also validated the emulator against latest voter versions. Voter is the compliance tool. Okay. So here on this slide, as you can see, we have created 10 controller working positions. And when you click on a particular controller working position, it provides the list of parameters. And if you look into these parameters, you can see that we can configure all the SIP parameters, RTP parameters. Okay. And apart from that, there is a wide range of ED-137 parameters, which are like, for example, configuring the PTT type or configuring the radio type, like whether it is a trans receiver, transmitter, like that. So it provides all the mandatory option to modify and edit, configure both the mandatory and optional parameters from the ED-137 specifications. Apart from that, it has some enable and disable feature for the advanced features. So we can, so like this, we can easily configure multiple controller working positions. Okay, and apart from this, we do support simulating the 4 RTP header extensions, that is like climax time delay, signal quality index, radio remote control, and dynamic delay compensation. So either we generate these messages, or if we receive these messages, then we are going to send the appropriate responses for that. Okay. And regarding the traffic actions, we can, on the established call, we can send a pre-recorded audio, and we can record the audio also. We can send and detect the digits and tones. We can talk using the microphone connected to the system, or we can even play the incoming voice to the speaker. So yeah, we can also introduce the impairments in the generated RTP traffic. So basically, these impairments can be like packet losses, different kind of packet losses, like burst loss, normal packet losses, duplicate, out of sequence, latency. Okay, based upon the configured values, these characters will be reflected on the RTP traffic generated. So this helps a lot in performing a pre-deployment kind of testing to see how the newly procured equipments are going to handle these kind of situation, because the whole of IP traffic is prone to all these impairments. Okay, so we can deliberately create these scenarios and verify whether the equipments or the network is able to cope up with these conditions. Then on the codec front, we do support ELA, EULA, and G729. These have been the standard protocols for this air traffic domain. And we do support automation of all the calls and the traffic that is being generated on the call. And with the installation, we do provide some automated test scripts which will perform like PTT and squelch actions automatically for the configured number of iterations like that. So here you are seeing a emulator with showing some of the calls, air to ground calls received at the radios. So as you can see here, this is the zip call control.gls, the base script, which is going to emulate all the air to ground call scenarios. So all these scripts come with the installer. So there is no need for the user to create his own scripts until and unless he wants some customized scripts and all. Okay, and it is going to indicate to which GRS the calls are placed, what is the controller working positions, and the status of the call as and when it progresses. And we do have some buttons for event buttons to perform certain events like keying PTT or the squelch. And we do have some event buttons for the advanced features like applying signal quality index and all. And the user can also define what are the pass and fail condition criteria for the calls actually. Okay, and in the below, we are providing the call graphs and also the message decodes, which will help in diagnosing any issues with the call or the messages that are being exchanged. Okay, and we can also simulate hundreds of simultaneous air to ground calls to perform load and stability testing on the equipment or on the network. We can also detect and report pilot and controller pilot induced synchronous transmissions. Okay, so here we actually provide a very detailed logs also, wherein we log every occurrence of the synchronous transmission start and stop times. And we also give the counters, like categorize them as whether it is this synchronous transmission was introduced by pilot or the controller pilot. And we give the counters also, like how many times the pilot SCT has been detected and how many times controller pilot SCTs have been detected. And apart from this, we do whenever this SCT occurs, we are also recording the voice automatically. So we have a separate script for this, which will take care of recording the voice automatically, so that user can listen into that voice and see whether there was any pilot voice was there, or it is like the controller pilot voices were there. So on this slide, we are just pictorially trying to present like how a single instance of radio can simulate a multiple controller working positions or multiple ground radio stations. And we can simulate all kinds of radio calls defined by the specification. So with this slide, we concluded the radio emulator, and next one is the telephone emulator. So telephone emulator here, it simulates the ground-to-ground calls as per EUROCAE volume 2 telephone interfaces. And here again, since it uses the same framework, that is MAPS, so it is again a software only product, and it also has a support for Python APIs. So let's go into more details about the telephone emulator. Okay, it simulates all the controller working positions, which will be used for simulating the ground-to-ground calls. And we support both B and C versions of the specifications. Okay, we can simulate again like hundreds of controller working positions. And apart from that, the telephone specification also has some addendums. There are some 8 addendums, out of which we support FA legacy telephone networking, and override calls, voice calls. These are the three additional addendums which we support them as optional capabilities. Similar to radio, again, the telephone is also supports the IPv4 and IPv6 addressing, and it is also validated against voter version 4.1.33.3. So going to the next slide. So again, as you can see, there are some controller working positions have been created, and on the middle pane, you can see like the all the ground-to-ground related parameters which we can configure. For example, what should be the subject like DA calls, what should be the call type, priority of the call, those and all. Okay. So yeah, so this ground-to-ground calls, there are a lot of varieties like IA, DA calls, monitor calls, and we also have a different kind of call scenarios also. For example, call hold, call transfer, call pickup, call intrusion, etc. And we do have the conference calls also. So we can simulate all of these call scenarios. Okay. And we can also simulate negative test scenarios to identify vulnerabilities, unexpected behaviors, and error handling capabilities. So I would stress on this point because since the product provides all the capability, ability to modify the messages, create our own custom scenarios, which can be like negative scenarios. So by creating these things, we can validate the other end product or the equipment which claims to be adhering to the ED-137 specifications. So that is the most important part of this emulators. Okay, and it also allows to simulate the all kind of SIP errors, be it be like 4xx, 5xx, or 6xx. So this will help in creating how the other end real equipment is going to react for these error messages. So it is in general, it is not possible to create all these scenarios in real time, but we can simulate these things and pre-verify all the messages from the equipments. So now we are seeing the ground-to-ground call generation window where you can see that we have established a ground-to-ground call. You can see all the messages on the call graph and the decodes. Apart from that, we are also trying to show in this figure like how multiple ground-to-ground calls or how multiple scripts can be run. For example, we can opt to run multiple scripts in a sequential order, or we can opt them to run in a random order. Okay, and we can also configure when to start the next script or the call. Okay, and we can specify how many times this calls need to be placed. We can specify a particular number, or we can just use a asterisk for running it infinite times. So as and when the test progresses, we also update how many iterations have been executed and how many iterations have been, what is the total configured iterations and how many have been executed. So this is like for performing a stress test, or you want to run a set of test cases so that you want to make sure that all the tests passes. Okay. So this is how the emulator is going to help in those kind of testing scenarios. So here also the emulator can generate hundreds of ground-to-ground calls simultaneously that may be used to create the peak busy hour or a peak busy minute scenarios in the network, so that the network before deployment, it is like either the network or the equipment before deployment, it is tested for all these limits. We can even try to create more than peak busy hour and peak busy minute scenarios and see how the equipment or the network is going to behave for these scenarios. So We also have a scheduler options where we can configure certain set tests to be run at a particular time of the day automatically. So we do have an option for that. So even in the absence of the engineer, the test can run, and all the results and logs will be saved to the folder. So again, we are just trying to depict the concept here with a single license of telephone. We can simulate hundreds of controller working positions, and we can simulate all kinds of call scenarios, the ground-to-ground call scenarios. So with this slide, I'm concluding the telephone emulator. Now we'll move on to the third emulator, that is a recorder. Okay. So here in the recorder, actually, like this is again, it is going to simulate all the recording sessions. Either it is for a to ground call, or it is for a ground to ground communications. Okay, and we are going to adhere to this EUROCAE ED-137 volume 4 recorder interface for this emulator. Okay. And similar to other emulators, it is going to have all the Python API capabilities and all the other standard features. So let's go into deep into the recorder emulator highlights here. So we do support both B and a C version of the recorder interface. And here we are going to either act as a recording client, or we act as a recording servers. Okay, when I say recording clients, so it could be like I'm acting a recording client at the CWP or at the ground radio station. In case of CWP, I may be trying to simulate the A to ground recording, or I can even try to simulate the ground to ground recording. So basically here we are not going to really establish any A to ground or the ground to ground calls, but we are going to simulate the RTSP sessions, real-time streaming protocol sessions, which are used for this recording towards the recorder. Okay, and we just try to create all the scenarios, whatever those are happening on an actual A to ground and ground to ground scenario. For example, be it be like keying the PTT or receiving the squelch. In case of ground to ground calls, it is like putting a call on hold, or making like something like a call intrusion scenario. So all those scenarios will be simulated directly on this RTSP sessions. So again, we can create hundreds of recording clients or hundreds of recording servers using a single instance of this software. And in this specification, actually, it defines 3 ways of transporting the voice. Okay, and we support all these 3 types, and these are basically like embedded binary data, where voice is carried over on the same RTSP control session only. Independent TCP, wherein we establish a separate TCP connection for transmitting voice only, or it could be like independent UDP. So there is a independent UDP channel to carry the voice. And again, recorder emulator supports both IPv4 and v6, and it is also validated against voter 33.4 version. So in this slide, we are going to explain some of the use cases here. So the first use cases is like emulator is acting as a recording client, either at the CWP or at the ground radio station, and it can simulate the required A to ground and ground to ground calls. So assume that there is a recorder vendor, okay, and he wants to perform all kind of testing before commissioning the product. Okay, so they can use the recorder emulator to simulate all the controller working positions or the ground radio stations, and create hundreds of recording sessions on the recorder. to verify the functionality and also the stability. So in the second case, assume that there are the VCS or the ground radio station equipment manufacturers, and they would have implemented this recorder interface in their product, and they want to simulate, verify this interface. So in that case, the recorder emulator can act as a recording server, and these equipments, the real equipments, can simulate the recording session towards the recorder, wherein the recorder will reply to these messages appropriately, and it will also record the information. So it is the same concept here, how to create the recording clients. Here we are trying to create the CWPs, and we can configure all the parameters here, as you can see. For all the these parameters will actually allow to simulate different kind of A to ground scenarios or the ground to ground scenarios. Okay, you can also see here what kind of call type I want to simulate, whether I want to simulate a to ground call or a ground to ground call. Okay, and we have option to specify all the recorder addresses, what is the client address and what is the server address, and we can also select the RTP transport type for this session. Okay, so basically in this recorder emulator, if we are acting as a recording server, we record all the incoming voice to a proprietary voice files, and we also store all the call data record information in the CSV formats, so that we can you can verify the recorded voice, and you can also verify the information that is sent by the real devices. Okay. So again, as you can see here, there is one recording session has been established, and these are the RTSP messages. And if on the right side, you can see all the decode of the messages. And these property names are nothing but the call record detail information, which will indicate who is the caller, callee, what type of call it is, the priority of the call. If it is a to ground call, what is the frequency, radio access modes, and all those informations. So all these informations can be configured for each of the individual CWP or the radio profiles. Okay, so it is just going to reflect whatever we are going to configure there. And it also provides all these event buttons. For example, if you want to simulate the voting scenario, okay, so you can just click on this voting button, so it will automatically create those scenarios and simulate it on the RTSP sessions. Okay, so again here we can create hundreds of recording sessions to perform the load and stability tests against the devices. So in this slide, we are just trying to provide some key updates regarding the emulators. So all the emulators support both B and C versions, and we always keep it upgraded to whatever the released changes over the standard specifications. And we also, like when we invoke the application, the user will have the choice either to choose the B version or the C version. So based upon the choices, we are going to simulate the calls as per the corresponding versions. Okay. And all our emulators support both IPv4 and v6. And we have also validated the emulators against the latest voter tools. And GL had also participated in the FA VoIP interoperability event, so wherein like a lot of equipment manufacturers had participated in that event, and they all used our emulators and monitoring solutions to facilitate the defined interoperability tests actually. And the EUROCAE is also planning to conduct a VoIP in ATM or IPv6 plug test, and GL is going to participate in that event also. GL is also a member of EUROCAE, and we do attend all these WG67 or the vote meetings to keep ourselves updated with the industry. And so by there we are incorporating all the latest changes that are introduced or released in the released by the EUROCAE. So with that, I'm concluding all the emulators. Now we are going to the monitoring solutions. Okay. So in case of monitoring solutions, as I told, we have two products here, but both of them work in tandem to provide the complete visualization of the network that is under monitor. So first thing is like the packet scan. As I told, it is a probe, IP capturing probe, which captures all the IP traffic in the network by connecting to a mirror port of the switch. So then it will segregate all these captured frames into air to ground and ground to ground calls. And by there, it is going to process these calls and derive all the deep down statistics for both signaling and the traffic. So once it collects all these information, it will be as and when these events are happening. So it will send all these call detail records to the central net server web database. Okay, and net server web is the web application which is used to which allows to monitor multiple probes running in the geography. So yeah, so we can have multiple probes which can hook up to the single centralized database, and thereby monitoring the entire ATM network. And packet scan can capture the traffic infinitely, and all the traffic will be captured non-intrusively. So this is the application you are seeing here. As you can see, these are the frames that are captured, and it identifies them as a SIP and RTP traffic and provides all the frame summary. And below we are providing all the complete decode of the ED-137 traffic. Say for example, here we have all the PTT, PTT ID mute informations, and we also decode all the 4 types of header extensions. Okay. So by decoding these messages, and then it collects all the required statistics related to air to ground and ground to ground, and these information is built as a call detail record, and it will be sent as and when it gets updated to the central database. So we can monitor up to like 2000 simultaneous calls in the network with this packet scan application. So in the previous slide, you saw the frame summaries. Now in this slide, we are showing the call summary where all the air to ground and ground to ground calls have been displayed here. Okay, and you can also see that all the signaling information and east and west directions traffic information is provided. So basically, this traffic information contains all the ED-138 statistics like mean opinion scores, packet loss, delay, jitter, duplicate, out of sequence packets. Okay, so all these call quality metrics have been calculated, and they are presented. And in below, we are again providing all the message graphs and message decodes for complete analysis of the call. Apart from this, we can also record the audio on the call. We can save these traces, and we can even import Wireshark traces. For example, you have the traces captured in your network at some other remote locations. You can just import them into packet scan and analyze the traffic to get the complete details about the calls. So here, pictorially, we are just trying to show some bad call due to some missing packets. Okay, the call quality has degraded to 2.77, which is not acceptable. And in case of a good call, which we consider 4.2 as an ideal small score for the good quality voice call, and it shows like there are no missing packets. Okay. So now we are landing on the second monitoring tool, that is a Net Surveyor Web. It is a web-based application, and as you can see, it supports multiple users, and it also has a very user-friendly graphical interface. So you can see here all the air to ground and ground to ground calls that have been captured or shown. These records are again picked from the central database, and as the central database is hosting all the records from all the probes, so we can have different kind of like a probe name based filters to view a particular probe's records. And apart from that, we do have some quick call detail record links actually. If I want to see only the air to ground calls or the ground to ground calls, or in case like good examples could be like failed calls or calls with a poor quality. So we can just click on those links and it will automatically filter out those calls and show it. Apart from this, we do have all the navigation and filter capabilities. That filtering is based upon the information it is there in the call detail record, the parameters, whatever we are considering as part of the CDR. So this is like a deep down information about a one particular selected call, where we provide again the call graph, the message decodes, and there is a event summary view which will show all the events that are happening in the on that particular A to ground or a ground to ground call. So you can see here there is a squelch on and a squelch off. And most important thing is we are providing the MOS scores and the voice quality statistics for every PTT and the squelch transactions separately. It is not like an average score. It is measured for every chunk of the PTT or the squelch. In case of ground to ground calls, it will be measured for a very short durations, like a windows of 10 milliseconds, and we provide the voice qualities. We also categorize them into like how much percentage of the call was good quality, average, and poor. And apart from this, we can also export the all these reports and call details. In this slide, we are presenting some graphical reports. You can see here the first graph is about how many answered calls and failed calls over a period of time. So this application helps to analyze both real-time and historical data. And for the failed calls, we are providing different reasons for failure. It shows how many calls have been failed with a corresponding failure. There is a MOS graph to indicate how the voice qualities have been varied over a period, and also the packet loss percentage. We can even customize our own graphs based upon the user requirements here. And apart from that, user can also define the alarms. So for example, if he wants to get notified for any packet loss in the network or degraded MOS scores, they can just define those alarms as and when these scenarios occur, and automatic email notifications and visual notifications can be sent to the user. And we also have a system to send a daily, weekly, or a monthly reports for the entire network. So I think with that, I'm concluding the monitoring solutions. Now the next course of slides will be presented by my colleague Nagaraj.
Thank you, Srinivas. Hello, everyone. I will be introducing you all to the GL's critical time delay and voice quality measurement solutions. As per ED-138 performance matrices, there are certain delay and voice quality requirements defined, okay, which must be met by the air traffic management network or the devices integrated into the air traffic management network. Delay and voice quality are especially important with the transition to the IP networks, which introduces packetization delays, jitter buffer delays, and other uncertainties. GL's critical time delay and voice quality measurement solution is a test suite of equipment designed by GL Communications to emulate endpoints, probe events of interest, calculate the signaling delays, measure voice delays, assess the voice quality across devices such as voice communication systems, gateways, radios, and other elements in the network, including end-to-end voice quality assessment. On the screen, you are seeing a typical air traffic management network, which includes different elements comprising both legacy and the VoIP devices. For example, in an essential scenario like measuring a push-to-talk delay between controller working position, which is on the far left-hand side, and the VoIP network, here are the different timing points of a signal or a voice event at various probing points in the network. Using GL's test suite of equipment, we should be able to calculate delays across devices and delays across the network as well. On the screen, we can see that timing references such as T0, T1, T2, and so on, these indicate the timing of an event at different points in the network. For example, T0 is a push-to-talk event that occurred at the analog endpoint, which is far left-hand side at the legacy VCS. Another reference is T2, which is push-to-talk event detected on the VoIP line. This event identified and extracted through ED-138 headers on the VoIP traffic. So this slide lists some of the important events for which delay calculation is critical. So these include PTT, PTT confirmation, PTT release confirmations, squelch break events, end-to-end voice events, transfer events, mute and unmute events, etc. Now, this particular slide shows how our test suite of equipment is integrated into air traffic management network to simulate analog endpoints, to simulate VoIP endpoints, probe and precisely timestamp the events at different points in the network. On the far left, we can see that audio analyzer, which is capable of simulating push-to-talk, inserting voice into the VCS at the analog interface, and then the packet analyzer, which sits in line between the VoIP endpoints, has a capability to filter the traffic, precisely timestamp the event at the line rate, probe and timestamp the events with nanosecond precision. Our probing devices support time synchronization using GPS if the probing points are geographically apart. If they are within the lab environment, devices also support daisy chaining for time synchronization. We have event data logger, which is a centralized device that collects all the events filtered and forwarded from the different probing points. We also have another application which is called Maps Administrator, which is a GUI based client that orchestrates the entire test scenario from emulation to the probing. It stores timestamped events, and in turn it calculates delay between those events, calculates statistics, generates test report, etc. GL meets all the critical specifications of air traffic management delays and voice quality measurements. So this is with respect to the GL's test suite of equipment for voice quality and critical time delay measurement. Now I will turn it over to our next presenter, Robert Bichevsky, Director of Engineering, who will talk about voice quality measurement in air traffic management networks. Over to you, Rob. Thank you.
All right, thanks, Nagaraj. So voice quality, essentially what that does is it analyzes the audio going through the network from point to point. So in this scenario, we're going to be sending audio from one end of the network, from the CWP, and capture the audio at the other end, and then analyze the captured audio against what was sent. Using a voice quality algorithm. We support two algorithms, PESC, which is based on ITU 862, and Polka, which is ITU 863. They both provide a mean opinion score of 1 to 5, 5 being the best, and allows you to understand what the quality was of the audio going across of the entire file. These are small files, like 6-second files. We use both male and female, different languages for different types of frequency responses going across the network. So this gives you, as I mentioned, this gives you a good idea of what the quality is. And we normally run the test over time to see if the audio quality is going to change based on load, based on different times of the day, things like that. So it's a good idea to just run the voice quality over a period of time. Okay, so the next couple of slides, we're just going to show how the solution that Srinivas and Nagaraj discussed, how this gets deployed. So in this case, this is, and in most cases, we're going to deploy this in racks, 1U racks. So you can see we have a 1U rack, which is essentially our central system with the Maps admin, our voice quality software, our Net Surveyor web. All that will be on one of the racks. And then we have other racks for our packet analyzer with our hardware built in, our audio analyzer with our hardware, and our discrete signal logger also with our hardware. And you may need multiple of the different racks, which is fine. They get stacked in a system, and then all get wired up, and then everything is run by the central system or the Maps admin. Now we can also, next slide, we can also deploy as a portable solution where we're sending out essentially probes, which is a small box with our hardware plus an embedded PC, and these are great if you need to be mobile. So we can move these around. You can take them out for a quick test and then bring them back. So everything that we do with our rack systems, we can also do with our portable systems, deploy them either way for the overall testing environments.
Thank you everyone for attending this webinar. And if you have any questions, you can feel free to contact us at info@gl.com. You can drop us an email, and or you can fill our information request form so that we can get in touch with you. And also please make sure to subscribe to our newsletter for a weekly information about our products. Thank you once again.